This lesson is on combining like terms. Before we can combine like terms, there are a few definitions we have to learn. The first is for coefficient. This is defined as the number that is in front of the variable. If you check out the examples below, negative 2x, x is obviously the variable. Negative 2 is the coefficient. Next we have w. It may look like there is not a number in front of the w. I like to call it the invisible 1, and I always tell my students to put the 1 in front, even if you don't see it there. And then obviously the coefficient is 1. The next one would have an invisible negative 1. The negative sign is already there. We just have to add the 1. The next term we want to understand is what exactly are like terms. This is defined as terms that have the exact same variable part. This can be a little bit tricky. So let's go through some examples and some non-examples. Some examples of like terms would be 2x and 5x, or 3x squared and 4x squared. Now, if you look at 2x and 3x squared, those would be non-examples of like terms. Even though they both have x's, they are not exactly the same. One has x to the first power, one has x to the second power. Let's go back to some more examples. You could have negative 7y, positive 9y. You could have negative 12 and positive 17. They don't even have to have a variable part. They could just be plain constants. Those are also considered like terms. Here's an interesting one, 2ab and 3ba. That would be an example of like terms. They both have an a and a b. It doesn't matter what order they're in. If you recall last week you looked at the commutative property, you can multiply in any order. So even though it looks like they wouldn't be like terms, they actually are. Let's look at some non-examples. Another one would be 5 and 7x. Obviously the 7x has an x, the 5 does not. 2x and 4y would be another set of non-examples. Next, we're going to look at just standard notation. So you have all these terms. What is the best way to write them? Typically, we put our exponents in decreasing order. So that means you would start with a term that has a squared power, and then you'd go down to a term that has, a variable to the first power, and then you would end with just plain numbers. So an example would be 11x squared minus 7x plus 2. Another area that you want to focus in for standard notation would be putting the variables in alphabetical order. So our first example had all x's. If you don't have x's, you might have something like 2x plus 7y. Notice how the x term comes before the y term. And then lastly, I had mentioned this before, you want to make sure that all your variables come before your numbers without variables. So some non-examples of standard notation would be 2 minus 8x. Here the constant comes before the variable. Another non-example would be 4y plus x. Obviously, this is not in alphabetical order. All right, we've got the basics. Now we're ready to combine like terms. Here are your steps. First, you have to identify the like terms. And I like to have my students do this by underlining or using different colors. We don't have different colors here, so we're just going to underline. So let's go down to our first example here. We would underline the two terms that are just plain x's. Those are alike. So what we're going to do is add the coefficients. Now remember, there's that invisible 1 there. So put the 1 in front and then add the coefficients. Standard notation tells me that the x term is going to come first. So my answer would be 2x plus 9. Second example is a little more complicated. We're going to think standard notation right away. So I'm looking at x's first because they're alphabetically before the y's. And then I'm also looking at exponents. So I want to do the squared terms first. So underline 6x squared and 5x squared. Add those coefficients to make 11x squared. Next, I'm going to look at just the regular x terms. So 3x. I don't see any other x terms to combine it with, so I'm just going to bring that along as part of my final answer. I'm noticing I have some y terms, so I'm going to underline those a little bit different. Sometimes you can use a squiggly line or any kind of a symbol that's going to show you that they match up. So negative 7y and positive 4y are going to go together to give us negative 3y. And then lastly, I'm going to go with my constants, and I've got 8 and a negative 2, which are going to make 6. And that would be my final answer.
Fine.